What's going on, you guys? Mr. Allen here. We are about to simplify these three dope radicals. Let's get after it. Let's get going. All square roots here. So we have the square root of 64, x to the 7th, y to the 10th, z to the 6th. Square root of 64, is that a perfect square? Heck yeah, it is. It is 8. Now, the next question is, we have x to the 7th. How many pairs of x's can come out? I can take out 3 pairs of x's, and that leaves me with 1 behind. I like to just jot it down up here. That's not an official mathematical notation, but it reminds me that's going to go in the radical in my final answer. Then I have y to the 10th. All right, so how many pairs of y's can come out? That would be y raised to the 5th power. 5 pairs of y's can come out. We're going to come back to that one in just a sec. Z to the 6th. How many pairs of z's can come out? Well, that'd be 3 pairs of z's. So I'd have z raised to the 3rd power. And then at the end, we have the square root of x left over because we had that one that just could not come out with the rest of the mathematical party. Now, as I said, we're going to come back to this y to the 5th and also the z to the 3rd. Back in the original problem, I had y to the 10th power and I had z to the 6th power. Any number that I plug in for y or z will result in a positive number once it's raised to the 10th power or raised to the 6th power. If I have a positive number raised to an even degree, it's positive. If I have a negative number raised to an even degree like 10 or 6, it's going to be a positive number, right? Do I have that same guarantee here with the y to the 5th or the z to the 3rd? No, I do not. So here's what we have to do. All right, so we have 8x to the 3rd. Then we have our absolute value bars for y to the 5th times z to the 3rd. We know that has to be a positive number for both of them. And then we will have the square root of x. All right. That looks terrible. Does not look simplified, right? But that is the process of simplifying a radical. We take what we can out of it and leave the other stuff behind. All right. Final answer on that bad boy right there. Beautiful. All right, let's switch some colors here. I'm going to go pink on this next one. Now we got multiplication. There's a couple ways to go about this. You can look for your pairs right off the bat and then deal with some things. Personally, I like to put this bad boy together. Okay, I like to put it together first, multiply the things together, and combine my exponents into one square root. For the 6 and the 12, if this is a non-calculator portion, here's what I'm going to do. I'm going to leave it as 6 times 12. I don't really care what that is, okay, because I'm going to break it apart anyways. You'll see what I mean in a sec. Then I have x to the 2nd and x to the 3rd. That's x to the 5th. Y to the 4th and y to the 8th. That's y to the 12th. When I multiply with like bases, I add the exponents. And then I have z squared just chilling on its own. Okay, so now I can just break this thing down. The reason why I didn't put the 6 and the 12 together is because I'm going to break these things down with a factor tree anyways. So I'm going to have 2 and 3 here. I'm going to have 2 and 6, 2 and 3. And now I can just look for my pairs. I got a pair of 3s and I've got a pair of 2s. So pair of 2s and then I got that pair of 3s there. Those come out and I multiply them together. 2 times 3 gives me 6. And I'm going to have that 2 left over. So I'm going to have a 6 here. And I'm just going to jot down that 2 so I don't forget about it later on. Remember, not an official mathematical notation to put it up there, but I like to do it so it reminds me. Okay, x to the 5th. How many pairs of x's can come out? I can take 2 pairs of x's, but there's 1 left over, right? 2 pairs would be 4 total, and I got 5 here. So 1's chilling back inside. We'll jot that in there later. All right, then I got y to the 12th. Well, I can have 6 pairs coming out with that one, y to the 6th, and z squared, I'm going to have 1 z that comes out. No leftovers. All right, so now I've got the square root of 2x. But let's do that quick check with the absolute value bars again, because this may not be our official final answer, okay? Not every class deals with this, but that is the appropriate way to do that. So it depends on the class you're taking, okay? Now, I had, let's see here, for my x to the 5th, that was an odd power. I don't have to worry about it being guaranteed positive, right, because it was to an odd degree, so don't have to worry about the x's. My y to the 12th, that was guaranteed to be positive, right? Y to the 6th, also guaranteed. Now, how about z squared? Guaranteed to be positive. Z to the 1st, not a guarantee. So what I need to do here now is I'm going to have 6x squared, y to the 6th, absolute value of z, and then the square root of 2x. Boy, that looks absolutely disgusting, doesn't it? Okay, but we did what we were supposed to do, right? Okay, so we multiply them together first, broke it down. That's dope, awesome, in America. All right, let's continue on. Let us continue. Let's see. What color do I want to work with here? I'm going to go back to blue. Okay, we'll do a little alternate, all right? Now, for this one here, I got a square root in my numerator, square root in my denominator. I got a 2 chilling outside of that square root. What in the heck do I do? Well, with division and multiplication, right? We multiplied, we put the stuff that was in the square root together, right? I can do the same thing with division here with the stuff that's in the radical. So what's 28 divided by 7? That's 4. And I got x to the 6th and x to the 4th. Can I subtract those exponents? Yes, I can. 6 minus 4 is 2. So here's what we're going to have. I still have my square root in the numerator. 28 divided by 7 was 4. And 6 minus 4 was 2. Exponent properties, I subtract. Boom. And this is all over 2 now. Ah, that's pretty cool. All right. What next? What's the square root of 4? That's 2. And the square root of x squared is just x, right? I can think of that as like we were doing here with simplifying, but these numbers work out so nice that we kind of just see that. So I'm going to have 2x over 2. Now what? Well, the 2's, they reduce, right? And I'm just left with x, but let's double check here. In the original, I had x to the 6th. Any number I plug in for x, guaranteed to be positive. Same goes with that x to the 4th. So I really need to say absolute value of x is my simplified form for that one. That was pretty dang dope, man. We had a lot of stuff just poof, go away. How did this all become just x? I'll tell you how, right there in those steps. You know what I'm saying? All right, dogs. That's pretty dope, pretty awesome. 3 awesome examples, all different from each other. Hopefully that helps and you guys found it quite radical, brah. I'm going to say that in all these radical videos. You know, so it's not going to get old, right? You just don't know when it's coming. Is it going to be at the end, beginning? I don't know. We'll see. I will see you dogs later.